Welcome to playing with the X bar distribution. So X bar is the symbol that we use for sample mean. So this is essentially the distribution of sample means. X bar as my way of typing this symbol. So this is the distribution of sample means. So again, we're going to look at that same distribution that I showed in the introduction to the distribution of sample means. So this simulation is looking at the change in points from a transaction at a store. And we have a list of 1,000 transactions, which had mean 0.498 in change and a standard deviation of 0.289. We are going to look at samples of size 10, samples of size 30, samples of size 50, and samples of size 100 from the list of transactions, and then record their sample means. And then we are going to study the distributions. So we're going to use that same applet previously used. We'll start off with samples of size 10 and see what we get. All right, so going back to change. We're looking at samples, and we'll start off with samples of size 10. So here's our first sample. We can see our little sample down at the bottom. You can see where it's coming from the original data set over here. And this one had a mean of 0.54. And so we have a mean of 0.54. Next up, let's go ahead and do another sample. Here's our next sample, happened to have a mean of 0.598. And so our mean of 0.598 is now joining the previous mean on our histogram over here. And then let's go ahead and do this for 498 more samples of size 10. The most recent sample has a mean of 0.618. So we can see that little blue section for our mean of 0.618. And we have a histogram here. This histogram is centered at 0.506. Standard deviation is now 0.090. It looks close to normal, but maybe not as nice as some of the other normal distributions we have had. So this is our sampling distribution of all the possible sample means if we were looking at samples of size 10. And I'm just taking pictures for when we go back to our notes. Next up, let's look at samples of size 30. Let's go ahead and just draw one sample to start off. Again, here's our one sample. This one had a mean of 0.489. So that 0.489 is popping up here. Let's go ahead and do this one more time. We have a mean of 0.497. So now here's our 0.489 and our 0.497 showing up in our histogram of sample means. And again, let's go ahead and add another 498 samples. Here's the most recent one, had a mean of 0.534. And we can see that sample up top in that blue bar. This is a little closer to normal than the previous one, still doesn't look perfect. These are now centered around 0.501 with a standard deviation of 0.054. Again, let me take a picture. And let's go ahead and jump up to samples of size 50. Again, we'll start off just with one sample at a time. So here's our most recent sample. This one happens to have a mean of 0.496. And there's that 0.496 for our mean showing up in our histogram. And let's do this one more time. Here's our next sample. This one had quite a few close to 0 with a mean of 0.484. So our 0.484 is now showing up on the histogram in addition to the previous 0.496, was it? And then let's go ahead and just flush this out with another 498 samples. Another 498 samples. This last one had a mean of 0.609. We can see that last sample far on the right of that distribution here. Now we're centered around 0.497. So let's go ahead and take this picture, and then we have one more to go. Let's go ahead and look at 100 in our sample. Here's our first sample of size 100. Those are all our data values. Again, we can see them being pulled from the original data set. And the mean was 0.496, so we put that 0.496 in our histogram for the sample mean. Draw again. This most recent sample had a mean of 0.437, and that 0.437 is now also on our histogram for our sample means. And then we'll go ahead and just flush it out to 498. Draw those samples. The most recent one had a mean of 0.467. We can see that blue segment for 0.467 from the most recent sample, as well as just the distribution of all of 500 of these samples, specifically looking at their sample means. So these are the various distributions with the mean and standard deviation of that distribution recorded. I'm going to go ahead and put this information into our notes, and then we'll make some comments. So here was our set for samples of size 10. So we're looking at samples of size 10. And we took 500 samples. The mean was 0.506. Standard deviation was 0.090. So the center of our X-bar distribution, we are looking at 0.506. And the spread, we are looking at standard deviation of 0.090. And for our shape, it looks close to normal. Could be normal or not, right? So the shape, it's close to normal. There's some up and down, but it does look to be more or less symmetric, right? Now, the actual mean of the data set was something like 0.498, if I remember correctly. So the center here is pretty close to the mean of the data set. The standard deviation, if we scroll up, was 0.289. So our standard deviation here is quite a bit smaller. Next up, let's look at n equals 30. So again, we're looking at samples of size 30. So in this case, we do have what looks to be, again, close to a normal distribution. It's centered at 0.501. The spread we have a standard deviation of 0.054, so an even smaller standard deviation. And the shape, again, is close to normal. If we look at our next one, for sample size 50, again, the center is very close to that 0.498. In fact, 0.497. The spread, we have a standard deviation, which is even smaller at 0.039. And then a shape, we're even closer to normal here. And then finally, let's look at our samples of size 100. The shape here is basically normal. The center is 0.499, and the spread, we have our standard deviation of 0.028. So some quick comments. Putting all of this together. Comments or observations. All of these X-bar distributions seem to be centered at about the actual mean of the population. So all of these X-bar distributions are centered right around the mean of the population. Data. In terms of the standard deviation, the larger the samples we consider, the smaller the standard deviation. So the larger the samples considered, the smaller the standard deviation of the X-bar distribution. And then for shape, the larger the samples considered, the closer the distribution got to being normal. So the closer the X-bar distribution got to normal. So this is just some basic observations. We can get a little more precise with the standard deviations. So if we look at a standard deviation for our samples of size 100 versus the standard deviation of the population, the standard deviation for samples of size 100 for the X-bar distribution is about 1/10 of what was the population standard deviation. It actually turns out that for standard deviation, we just take the population standard deviation and divide by the square root of n, and it gets what should be our standard deviation. It turns out if we consider all possible samples instead of just a simulation of 500 samples, the center should wind up being precisely the mean of our population. And then we'll have sort of a standard cutoff for at what point we consider the X-bar distribution to be normal. So in our next video, we will get into the more official facts of the X-bar distribution.